Welcome to LeChateliers Lab, Part 1B. So last time we were working with a reaction where Fe plus 3 combined with SCN minus to form FeSCN plus 2. This was clear, and this turned red. And I know it was a little bit different data table, but I'm going to use this different table to highlight some things and talk about what we're going to call equilibrium shifts. But anyway, we saw with the first thing added, it got less red. The second and third thing, it got more red. And the fourth thing, it got less red. So we're going to look back at LeChatelier's principle, look at these effects on concentration, and see if we can make predictions or at least understand why things turned red and find a systemized way to understand that, or things became clear. Okay, so the first thing we want to do is just understand an equilibrium system and what's going on there. So we're going to take this away for a second, and I'm going to bring in these Legos, and I have some Fe plus 3. The red Legos are going to be the Fe plus 3. The brown Legos are going to be the SCN minus. And if I put these reactants together, they're going to combine to form FeSCN plus 2. And that would be a simple reaction, which is a synthesis reaction. So these things are going to combine, and whoops, I put this on wrong, and I'm kind of hiding this from your view, but it forms a product right there. Okay, so Fe plus 3 plus SCN minus forms FeSCN plus 2. Well, in the old days, before when we just moved in one direction, we would, again, I'm doing this backwards, and I'm going to put this one right here, and let's do another one right here, and we're going to go until something runs out, right? Until our limiting reactant runs out, which looks like it's over here. But this is equilibrium. And what happens is these two things are reacting to form this, but now we're starting to see it come back and split up apart. And then something else is coming back together. And something else is splitting apart. And if that rate of coming together and splitting apart becomes the same, that's when we've established a new equilibrium. Notice at equilibrium, we do not necessarily have the same amount of reactants here and here, or the same amount of products, but the rate of these two reactants forming this equals the rate of this product breaking up into these other things right here. So Fe plus 3 plus SCN forming FeSCN plus 2 equals the rate of FeSCN plus 2 splitting up into these two things. That would be an equilibrium system right there. So now we're going to apply a shock to this equilibrium system. Okay? And this is all in balance, but now I'm going to throw a bunch of Fe plus 3 into the system. And the system's going to be wanting to try to get rid of it. So I threw a bunch of these in here, and the system goes, oh, too much Fe plus 3, I'm going to try to get rid of it. Just like if you won the lottery, oh, too much money, okay, and the government would come and help you out by taxing you on some of those earnings, because that would be too much money for you, and then they can help establish equilibrium in the markets. So some of this that I added is going to react. Some of the Fe plus 3 that I add is going to react with SCN minus. And more of the Fe plus 3 is going to react with SCN minus. And then maybe more of it's going to react to form SCN minus, or I'm sorry, the Fe plus 3 with SCN minus to form FeSCN plus 2. So the Fe plus 3 is reacting with SCN minus to form FeSCN plus 3, or plus 2. But then it's going to start splitting back. Some of these are going to start going back in the other direction. So, and you're going to go back and forth, and you're going to establish a new equilibrium. Now, what happened was, ultimately, this went up by a lot, but some of it went back down. This definitely decreased, and this one definitely increased. So if I go back and look at this system that I have here with this chart, we can see that make sure we have everything in here, is if I add Fe plus 3, it goes up initially. But some of that I added is taken away. And is that what happens is some of the Fe plus 3 that I had will react with SCN minus, making that decrease, forming more FeSCN plus 2, okay, or the combined Legos in this case. The FeSCN plus 2 is the thing that's red, so it's going to make it more red. In other words, if I add something to the left-hand side of the equation, remember this is a cutting line, it's going to shift away to try to get rid of it, or at least part of what I added. So shift away from what I add. I add something here, the equilibrium shifts this way. Where the arrow points to will get bigger, where the arrow comes from will get smaller. So the net effect is this went up and went down, this only went down, and this one only went up. So the SCN minus decreased, the FeSCN plus 2 increased right there. Okay, let's take a look if we added SCN minus. What's going to happen? It's another reactant, so it's going to go up initially, but then I'm going to try to get rid of some of that SCN minus that I added, so it'll decrease. And as it decreases, it'll react with Fe plus 3, making that go down as well. Okay, so that decreases. But if I add a reactant, it's going to shift to the right, and that's going to make the FeSCN plus 2 get bigger, or the product get bigger. Where the arrow points to gets bigger, where the arrow comes from will get smaller. And if the FeSCN plus 2 gets bigger, it'll get to be more red. We'll take a look at that and watch it in action with our Legos. And what I'm going to do is throw some SCN minus into this system, and what's going to happen. I threw a bunch of those in. Can't see them all there, but there's quite a few there. And the system say, oh, too much Fe plus, or too much SCN minus, let's get rid of it. So I'm going to take SCN minus, and I'm going to take one of these, and I'm going to combine them together, okay? And then what I'm going to do is take another one of them, and then I'm going to combine them together and put it over here. So I'm grabbing the Fe plus 3 and the SCN, and then I'm making more of our product. Now what's going to happen is I'm going to keep going, and these might combine, but then you're going to start to get the reverse reaction. So it's going to even out. Reactants going to products, and products going to reactants at the same rate. Okay, so I'm going Fe plus 3 to SCN minus, going to this, and SCN minus, FeSCN plus 2 going back to SCN minus and Fe plus 3 right there. Okay, so now let's just look at one more case right here. And what if I take away some SCN minus? Let's take a look here and bring this back. Okay, we're getting a little unbalanced here, but let's say I add Hg, which removes SCN minus from the system. So what if I remove SCN minus? The system would want to say, hey, I took something away. It's kind of like if, let's say, you had a fire in your house and you got insurance. You lost something, but you get compensated for that. Or somebody stole something from you and maybe insurance would cover it and you get some of that back. So if I take something away, the system shifts left, and what happens? The SCN increases and the Fe plus 3 increases, but the FeSCN decreases in that process. And if the FeSCN plus 2 decreases, then it's going to be getting less red. Now, what's going to happen is, let's show this, and we are going to take away some of this right here. Okay, and what's the system going to do? Oh, we need to replace some of that SCN minus that we lost. Some of the FeSCN plus 2 is going to break up into this, and some more of it's going to break up into SCN minus and Fe plus 3. Now it's going to start going back and forth, and we're going to reestablish a new equilibrium. So this decreased, some of it was brought back, the Fe plus 3 increased, and the FeSCN decreased, and that's why it became less red. We could go to one more example, and I don't think we're going to show it with Legos, but if I took away, if I added Cl minus, which removed Fe plus 3, it's going to remove something from the left side. Part of that's going to be replaced. making the SCN minus also increase, making the FeSCN plus 2 decrease, and it becomes less red in that case as well. So what was your assignment? Your assignment was to look at, on page 3, you're just filling in, does it increase, decrease, or no effect? Well, we notice all of these had an effect, and it's either increase or decrease, and you can look at the systems, and you can match it up to the arrows right here, and you can understand, or you can see which one happened. Did it increase or decrease is just what you're answering for those. An up arrow means increase, a down arrow means decrease. So it's not just about filling in the arrows. Ultimately, it's about understanding it and understanding equilibrium. So as we get better and work through it, we're going to be able to make actually predictions on which way systems are moving with equilibrium. Thank you.